Okay, this is Derwin King at Sampson Community College, and this session is with MNT 110. And today we're going to be doing setup and adjustments for clutch and brake setups. We have the first one is for a pneumatic clutch and brake setup that could be comparable to air brakes on a transfer truck. This air actuated disc brakes. Instead of it being hydraulic on your vehicle, if you're driving a car or a regular truck, whenever you hit your brake pedal, you're actuating hydraulic fluid that's actuating your brakes. So it's hydraulic brakes on most vehicles, but on large trucks, it's actually air. And so we're going to move over to here, and let me get and we have Luke and Darren. They're doing a setup here. We're going to see what corner they at right now. That's quite a fancy tool. Yeah. That way it's not a tricky kind of flat for the pole. Sorry, now it's just a drop. You whip that lined up. I'm going to get the camera over here. Thank you. Yeah, appreciate that. If you'll lift that off there, yeah, lift the camera first. Lighten up on that side. Because of how lightweight all this here and how small that shaft is, I would actually say go a little bit lighter. Lighten on up some more. Lighten up. Hold right there. Even though Gates doesn't make a tension tester, but remember they said in that statement in there that the minimum tension on a belt, as long as it doesn't slip under full load, is okay. Remember just reading that. I'm going by how kind of lightweight this thing looks and how small that shaft is, and we're sitting way out, so there's a lot of leverage on pulling that thing as far as warping, bending it. So I would actually say go as light as you can so it doesn't slip. That's probably, and it's subject to opinion too. I don't think I'd go any heavier than that, to tell you the truth. So for Patrick and Brandon, whoever may be watching, the tension here, we got it set lighter than the tension tester would have us do it. But this mechanism, that air clutch right there, it's kind of, I would hate to use the word flimsy, but it's a little kind of a lightweight looking thing there. That's a small shaft. I'd say it's best off to go lighten up here. And then the next thing that I want to check out in their setup would be you got this is the stationary part of the brake pad, and then the movable parts over here just being pushed by the airline to, like you see. So the airline's on this end. This part of the pad here moves in. The vacuum pad right there, we want to have it set as close as we can without it touching. Right now, it's spinning nice and free. And if you will, get that 10,000 shim, the 10,000 feeler gauge, and you have a little bit of drag in it. You feel some drag. You don't. But it looks like a lot more than 10,000. What I would do is loosen the set screws up and bring it back until you get a little bit of a drag there with 10 pounds. And then there is drag.
The other side don't have them.
Okay, so if that's the case, and all this is tying here, is there? Oh, that's tight. Let's see if we can. What can we do to maybe even that out possibly? Because that bigger gap, what's going to happen is when that pad pushes, it's going to flex that. It's going to flex this the rotor. You know what I mean? It's going to flex it. It's going to push, and it's going to have a tendency of making it buckle like that. How much of a gap is in there right now? If you kind of increase the feeler gauge, can you figure? You can put like a 30 in there. See if they're 30 or whatever it may be. And actually, what you just did right there, Darren, that thing is actually floating. It darn thing moves. We're not even going to really be able to depend on that. Just really throws another whole light on it right there. That throws another whole.
That's what I was looking at. This back here, it's great. I mean, it's got the same power inside.
Mm-hmm. And because of the way it just snaps in with some clips, this is not going to be a super accurate way to measure anyway. But what I would say is, here's what I would do. Loosen your set screws again. Tap it this way. Just tweak it until we don't hear anything scrubbing, and see if you can get maybe just a pinch closer. Okay, you don't think we can? See if you check again. You've already tried that. We're going to leave it alone.
All right, I had to keep moving it back.
We're going to leave it alone. Okay, so you've already done that. We're going to leave that alone. I'm going to take the word for it. Okay, we're going to leave it alone. So before we actually fire up the motor, we're going to do this. I want you to engage the clutch, and let's see. The brake. Engage the brake. Let's turn the regulator up a little bit. Just go up maybe 20, 25 pounds, something like that. That's actually fine right there. That's good. Now, so go neutral and then back. Let's watch that. Okay, do it again. Open, spin. That's not bad. I don't really see much of a flex there. Do it again. That's fine. Ain't nothing wrong with that. Not a thing wrong with that at all. You see that? I was looking to see, did you see it really flex? But actually, that's fine right there. And then, so now we're going to get out our guide that's going to tell us about the pressures to start out with on the clutch and the brake. And then we're going to go through some adjustments to give you a soft start and a soft stop, and then they'll change it. So let's get, actually we can read. Let's get out of play computer. Go through the adjustments here. So this is our guide here for this pneumatic clutch and brake trainer. That's a bird's eye view of all the components. So you've got your motor here. You got your driven, and got your belt drive. You got the directional hand valve, like a directional control valve. You have a clutch regulator over here for air, and then one for the brake. Main disconnect switch and so on. Okay. So if we go, and I'm just going to put the paper here where you can kind of read along, Patrick and Brandon. Let me see if there's anybody in the session. I don't know. Nobody in yet. Let me shoot Brandon a message real quick and remind him. I don't know whether he's. Okay. So I sent him a text out to remind him just in case if he's able to watch. All righty. So here we go. I'm going to hold this up while I'm reading. So we're going to start out with the directional valve in the center position, and we are. And you'll adjust both regulators to read 0 psi. If the needle flow control is installed, open it one full turn from closed. So you'll zero both of these. And then the needle valve, which is like a speed control for that clutch, close it all the way and then open it one full turn. So what he's doing here is he has there's a needle valve in there that runs from the clutch regulator. This regulator, air regulator is for the clutch. This is an inline. You have pressure adjustment for the clutch here, flow control here, which will be for speed. This is for pressure, and then a flow control is actually for speed. And that goes up here to the clutch mechanism, and that's going to come into play to actually give you like a soft start, a very, instead of a jerky start, it's going to help you have a soft start. Okay, and then so you've got both of these regulators here for the clutch and brake at 0, when you engage them, go left and right with them. Show them. 0 on the left, 0 on the right, and then you've got this here set for a 1 full turn, right? Okay. Next thing is we're going to plug in the power to the motor, and we're going to turn the directional valve in both directions. Make sure that there's no objects laying around. They don't have any tools in here. Nothing laying around to get hit or pump. So good. Right? Got glasses. Everybody got glasses, safety glasses. Yeah. And we're gonna unlock the trainer, and we're gonna run the lever in both directions to attempt to actuate the clutch and brake, but nothing should happen. Except the motor shiv and belt should be. The motor's gonna rotate for sure, but the clutch won't engage yet. At that point, we're going to turn off the motor, and then we're going to turn the directional lever to the left, the clutch, and adjust it for 5 psi, and then return it to the center position. So let's get it unlocked. And all that's folded down. Actually, that right there is loose. Is there a?
This is the snap on it.
Yeah, but isn't there a screw though? There's screws. Yeah, the screws. Yeah, that's actually loose right there. There we go. Yeah, that's a cover for a starting capacitor. It ain't supposed to be loose. This is an 11M1. It's got like 3 nut drivers and a bunch of tips on there. That's a nice, real nice driver right there. What we got here is the cover for the starting capacitor. There's a start capacitor in here for a single phase motor. It gives it a boost to get it started. That cover was loose, and he's just tightening those 2 screws there. So what I was doing is kind of jiggling stuff to make sure there wasn't nothing loose, and all of a sudden that's rattling. So anything that rattles like that, it's it's going to make you think something else is wrong. They used to drive my dad nuts, so he'd be going down the road, he'd hear a rattle, he couldn't stand it, drive him up the wall. So he found it. You could have change thrown in the ashtray, change in there, and if it rattled, it'd drive him nuts, and he figured out what it was. He'd say, "What is that? What is that noise? What is that noise?" he wouldn't stop to figure out what it was. Okay, so now we're going to unlock this thing electrically. You see here, we got a lockout device, and lockout tagout is a major thing in plants nowadays because of accidents and workman's comp cases now. So you got that nice little lockout deal there that makes sure where nobody can power it up while it's being while the adjustments are being made. So let me get my Zoom mobile over here. Got it in the off position. I'll plug it in. Okay, now, so when we start out, what you'll expect is this. Overall view is there goes your disconnect switch for the motor. This is actually the motor starter. There's no contactor. It's a real heavy duty switch that breaks the leg on that single phase motor. It's 120 volts there. So this is actually just breaking the hot wire. And it's a really heavy duty beefed up switch like on the wall, but way heavier duty. And there's also inside of there, there's an overload in there that if it draws too many amps, it'll actually trip like a breaker. And this switch will actually flip to the center and be spongy like a circuit breaker. So it's actually a motor starter, but it's a manual motor starter. Very heavy duty switch there. As soon as we cut that on, the motor's going to start, the belt's going to turn, it will turn the clutch, but the clutch is not going to engage because we don't have any air on it yet. Because there's zero PSI right here. So I'm going to let one of y'all, if you, one of you will turn this on and watch out for your coat now. There's no guards on this. Just let me cut it on. And now, so if you notice here, you got the motor turning there. Gear turning there. So the motor's turning, the belt's turning, but yet, if you look at the output shaft there, the shaft is not turning where it leaves the clutch. So that part there's not turning. Our rotor's not turning, and that's because the clutch itself is not engaged because there ain't no air. There's no air on it from down here. That's the whole reason there. No air. That's not engaged, so the rotor's not turning. So it tells you to set this here to engage it both ways and make sure that you don't get any movement. No movement. Go back the other way, and then that's for the brake cord. Now, so we want the, it said to go to 5 PSI here, so adjust this one. You want to go over. Okay. So now, if you look at what's happened here, actually go a little bit louder. I think that's 10. I think that was 10. Kind of back up a little bit. And then now kind of working back and forth to the switch. Make sure you sort of half of that. Exactly. That's about 10. I mean, that's about 5 right there. Do it again. That's probably, yeah, that's pretty, that's close enough on it. Now, so now, let's put our camera down. Our next step is going to be, we've done that. At this point, when you engage the brake, okay, go to the left and let's watch it engage. Hold on, yeah, hold on. You're going to have to give it just a pinch more on the air until you actually get a little bit of a reaction there. Yeah. Oh, yeah, that's it, yeah. Now, when you move it, he's engaged and turning right now. But what happens when you go to the right with the valve to make it brake? It's not going to stop because there's no air pressure. Well, you didn't want to, Doc. We're going to show you that it wouldn't stop without air, though. You want to zero it out. Now engage it. Okay. That's it. So look, he's turning right now. The clutch, he put a minimum amount of air in there, which was around, around 5 PSI or so, and it did engage. It did engage the clutch, so it's turning. But yet, when he goes to the right with it, because there's 0 pounds on the brake regulator, it's just sitting there freewheeling. The brake cannot engage because there ain't no air pressure on the brake. That's a bad thing. It'd be bad to be up in the mountains like that, and your regulator go bad. You'd have to find you a pile of sand right to run into, like they stuff in the mountains. You have to find one of them. I don't see one right here. I don't see no pile of sand, so we're in trouble. Okay. So what does it say, dude? The amount of air. Let's go up to here. Let's flip on over. You want to adjust the regulator to read 15 PSI on the brake. Yeah. Right, that's 15. Now let's back up. Let me get my backup view here. And now if you engage me get back up here where I can see what you're doing and everybody can see the actions here. So step one, go to the left to engage the clutch. He did that, and you see that the rotor's turning. And now go over to the right to do the brake. And so you have kind of sort of a soft stop in there. It's not really what you call a hard stop. All right, do that again. Go to the left. You got a very soft. Well, don't push it like that. You want to let it do it itself. If you have to tweak the clutch area, you can, but let it do it sort of on its own. So you're engaged now. Now go to the right to do the brake, and that's a very smooth controlled stop. Now start it again one more time. So that tells me that you need just a pinch more air, just a smidgen. And just like a lot of things in maintenance, you've got to fine tune things. So now shoot on over to your brake. Nice. Now go back to do your clutch. That's still a little bit weak, isn't it? Okay, so he brought it up a little bit closer to about 8 pounds. Now shoot on over there to your brake. Good. Now hit the clutch. That's quite a bit of a delay there. I'd say kind of increase a little bit. Good. And that hit your brake. That's nice. Go clutch. Okay, that's not too bad. And then brake. Pretty good. Now engage here. There you go. Very nice. I mean, what do you think, guys? A very soft start and also a nice soft stop. Go ahead, hit your brake. That's as good as you're going to ask for right there. Very nice. What do you think? Nice and smooth. That's the way you would drive a car, ain't it? When you're going up to the stoplight, do you slam on the brake or do you go real nice and smooth and easy? It depends on what. You guys are YouTube stars now, okay? So you're on the MNT channel here at SCC. So and I pay you if I could, okay? But these guys, whoever's out there in YouTube land, give it up for these guys here. Give it up here for Luke and Darren. Woohoo! Okay, all right. So y'all clap Patrick and Brandon. So here we go. Yes. All right. Now let's see what it says on the adjustments this time. I think it's got a little bit more to say in here. They're saying in step number 8 here that you can actually fine tune the soft start by adjusting the flow control. You can actually get a more controlled soft start doing that. So watch your sleeve there because it can get hung. Right. So as you increase that flow control, and y'all watch what he's doing here. He has an air regulator for pressure, a needle valve for speed. So he's continuing to open it a little bit, and he's getting a much better reaction time on the clutch with having the flow control tweaking it in, guys. You see that? Faster reaction time, but yet it's still nice and smooth, isn't it? Now you're cooking with gas, man. You're cooking with peanut oil, okay? Now that right there is absolutely beautiful right there. So a lesson that applies to hydraulic and pneumatics is that air regulators, they adjust pressure, and that's how much actual push pressure do you have, and then that flow control over there is gonna slow down the speed. So that's for speed and that's for pressure. So that's everything that you can control cylinders, whether it's a cylinder or a clutch mechanism like this, it's the same principle of pressure and speed. So on plant equipment or in any type of industry like that, if you want to have maximum pressure but nice and slow movement, you jack up your pressure here. You can go like high here to get a lot of push, but you can slow it down with that flow control and have a very powerful push, but slow. Like very strong now with PSI, but slow getting there. So it does a slam and break thing. That makes sense? So y'all think like that when you're making adjustments out there, whatever it is, power here, speed here, fast or slow. Make sense? You always want to kind of watch out your limits here, that you don't damage something out here on whatever the specs is, the requirements of your machine. So that was an awesome setup, I think. Very good. What do you guys think? Okay, good. If you picked up anything that may be new to you, or as far as adjustment wise, exactly, the flow control. So that little flow control is an important player in here. And let's talk about another thing about the flow control that you may not know, and that is when we zoom in on that flow control, there's an arrow pointing to the left. Does anybody have any idea what that arrow means? This stamped on that arrow. And see if there's a word on there. Can you read a word? Oh, it ain't okay. It's actually, look, it's a double-ended arrow. Let's look at the arrow really good here. The arrow is a large pointing to the left and it's small pointing to the right. You see that? Notice that the arrow has a large arrow pointing to the left but a small one pointing to the right. You see that? So anybody got any idea what that means? Okay, so I'll tell you what it means. Right, exactly. Look, the arrow to the left is very large and the one to the right is very, very small. So what that means is you have free flow to the left and you have metered flow to the right. So whenever the you disengage the regulator here, when you disengage it here, and the air pressure, the exhaust actually comes back through here to exhaust out the valve here, then the reverse flow will actually be free flow to the left, not restricted. But when you apply pressure here with the valve through the regulator out to clamp that, to engage the clutch, when the pressure is going to the right, it's actually metered by the position of that needle there. So I'm going to show you how that works there. So let's cut the motor off. So here's a lesson from hydraulics and pneumatics. So let's go here. That's actually a real good position right there. Let me get a piece of paper. I'm going to draw you a diagram. There's a check valve in this thing, a ball. It's a check ball. So here you have an air line. Let's go. Actually go. Here goes the air line right here. We're going to the regulator. And then we go through a needle valve. And the needle valve symbol looks like this. It's a curved line, and it has an arrow going through it that means that it's a variable orifice. It's a variable orifice that's adjustable, that actually the plates can close in when you adjust the valve. it can close in and pinch off and slow down the airflow through this thing. So that's a plain needle valve right there. Without, and this type of a needle valve here, the way it works is like this. If the airflow is going this way, it's metered. If the airflow goes that way, it's also metered on a plain needle valve. So it doesn't distinguish between the directions, but actually give you the same meter effect in both directions with a plain needle valve. So this one actually has a bypass check built into the valve, which means that parallel inside of the needle valve, you have a check valve. And it goes like this. You have a ball check, a V, and it is actually that, y'all recognize that being a check valve? That ball, let's draw the ball close against it. The ball goes against the seat. There goes the seat for the check valve right there. And we have a ball. The ball sits up against it, like that. So when you have airflow, let's do one scenario. I have airflow shooting this way. So the airflow gets to here, to this assembly. The ball check and the needle valve, all of that is in that one thing there. That one thing contains both of those within it. So it's all embedded in there. Come back to here. Here's what happens whenever you shoot air toward the clutch. We're going to have the clutches out here. The air comes to here to this junction point, and it tries to go straight, and it tries to go that way at the same time. You know, air pressure is going to try to go both ways, right? It's naturally going to try to go both ways. So what happens? It meets some restriction here with that needle valve, so if you don't have it fully open. It sees a little push, so it says, I'm going to see if I can go around this thing. I see another line. Let's see what happens over here. So it goes over here, and that ball pushes against the seat. What happens there? It closes because the ball shuts against the seat. So there's absolutely no airflow going that way. So you have to go metered flow through this. And so that's the reason for the symbol that does this. The symbol that's drawn on that thing has a big arrow like this. Orange arrow. And then a small arrow. So the small arrow means that you have metered flow, metered flow to the right. Somebody got it. Then when you release the regulator, when you cut the pressure off, that clutch is going to actually have a backfeed of air to exhaust back out through the regulator. So if we change the direction here, and the air is going in reverse to exhaust out through the valve, the hand valve, then what happens here? You have air pressure going this way, and it tries both paths, doesn't it? Well, it meets some restriction here, but so it tries to go here, and it also tries to bypass. So what happens here? It pushes the ball out. You see that? It pushes the ball out, and then you actually get less resistance through here. There's free flow here, so it's naturally going to kind of go on around there. It's going to go on around there and go out that way, and so you get the large flow to the left, so you get free flow to the left. Free flow with no restriction at all, and so that's what you call a flow control with a bypass check. It's a flow control with a bypass check is what that is. And technically, if you don't have the bypass check in there, and it's nothing but the valve in there is called a needle valve. So technically, in our book in hydraulics and pneumatics, which I'm going to be teaching that in January, if you see just that symbol alone and it's a bidirectional flow control, it's just simply a needle valve. And it'll give you the same effect in both directions. And in some cases, that's actually what you want. Maybe that's what you want on a machine, maybe or maybe not. But here, that's not what you want. You actually want to have a quick release. When you engage the clutch, you want the clutch to be slow acting but fast releasing, right? That's kind of what you want. So that's the perfect application of the a flow control with a bypass check. So all that is together. So that's a good application there. And if any of you have not had the hydraulic and pneumatic class, if you're going to get your degree, it's a required class. It's HYD 110. I'll put it down here so you can see it. HYD 110. And it's an awesome class. You get a lot of hands-on. There's a lot of good stuff in there, and I'll shoot the camera over that way. Way over on the other side of the shop, on the far side, we got trainers over there that we got hands-on setting up and adjusting and doing some troubleshooting on hydraulics and pneumatics over that way. So it's a great class. So now let's see. You guys have any comments you want to say to Patrick and Brandon about what y'all? What are your thoughts when you made the adjustments? Let's talk about you want to tell them how you got the gap fine tuned in here. How did you get that gap fine tuned without having to go and change, without having to break the taper lock loose, without having actually the QD bushing. That QD bushing is a big headache to try to make an adjustment because it's very time consuming doing that. So that last fine tune, that gap in there on that backing pad, tell them how you did that. I'm gonna put it up here. Tell them again. He loosened the set screws and also on that side. Show them there on that side. Set screw on that side. So if I back up a little bit, y'all point at both of them at the same time. You got the set screws that they loosened up, and they were able to actually move the shaft over that way and fine tune that rascal. And that's a whole lot faster setting that gap there than breaking loose that QD bush in there. For the initial setup, you had to set that up. But anyway, we want to work smarter, not harder. The place I used to work at, whenever you go to the time clock and put your card through to clock in and out, that display says smarter, not harder. Smarter, not harder, And so that's basically what these guys have done here. You got if anybody out there is looking, that kind of surfing the internet, and if anybody from Goodyear over there in Fayetteville, here's your man right here. There's your man right here. He's heading your way. And you might be too. I don't know what you want to do, but both of these guys are awesome maintenance mechanics and able-bodied, strong dudes. Got a good head on the shoulder, so when they get their degree done, they're heading out there. They're gonna tackle a lot of things and solve a lot of problems out there for industry. So we're proud of them. And okay, so I think that's the kind of stuff we get into in that hydraulic. I'll put a bunch of it. You took it good too. We're breathing. Okay, good. You remember seeing that in the symbols? Stuff like that. If you don't know stuff like that, you don't realize that what's the reaction going to be. You know what I mean? You just don't know up front if you don't know the components. That's the whole thing. Is you get a lot of theory here that I honestly never did get in the field. I mean, I ended up in hydraulics and pneumatics in the field. My degree's in electronics, and I didn't learn hydraulics and pneumatics out here. They didn't have it back in the 80s when I was out here, so I had to learn that stuff in the field. But you didn't get all of that out there. You were just kind of thrown in the middle of it and took the fixed stuff that you didn't even know what all of the devices and details like that. Come out here and I got into the books and discovered a lot of stuff with fluid power that it would have been nice to have known years ago. So anyway. That's pretty much it. So we're going to lock this thing out. So I'm going to let you guys do that. They're going to show you the proper lockout procedure to do. So Aaron there, he's unplugging it. That's power right there. He's going to come over and do an official lockout. put that lock on there. And because Patrick and Brandon, if Brandon can make it back, they will also do this. They're going to break all that down and do a setup. And by the way, the bushing that's holding that rotor is a QD bushing. You have the three bolts that actually pull it together, that clamp it tight on that shaft. And when you go to loosen it, you got to move these 3 bolts into these jack bolt holes, and that'll actually separate the bushing from the rotor there. So that's the QD versus the taper lock. The taper lock is used on the sprockets that we had. So now we're going to scoot over to an electric brake, a clutch brake setup, an electric brake, no clutch. We got to roll it over here. It's actually back in that room. We need to roll it out here. Yeah, I think I've left it back in the other room. Yeah. When you go through the door, look to the right, and it should be right there to the right. They're bringing the electric brake motor out here. I had to roll it into another room the other day. Gonna get some tools out for it. Okay, now we went over some of this the other day, but we're gonna do it again. This is an Italian brake motor that comes from the Butterball plant, and it's a very fast braking action to it. On the back of it here, we have a calibration bolt that when you screw it in, it actually releases the brake so you can set the gap. We're going to take that adjustment bolt all the way out and take the cover off to the rear for the brake. So you just actually unscrew it that way. Yeah. That's a special, exact, very precise length bolt that you use for setting that up. You just wiggle that in off. If you want to hold that in there. Right, there you go. And so here we have three studs here that have springs in them. And we have an electric coil, and you have friction brake pads in here, sandwiched between some metal plates. And the coil actually pulls and separates against the springs so that it can actually so it can rotate. We're going to get these out of adjustment here, these adjustment nuts. We're going to adjust these. We're going to loosen up the 3 outside ones and then take the 3 inside ones and jack them out and get it out of adjustment. And then readjust it in here for a 10 thousandths clearance in 3 points around the circle there of the brake pad. So we're shooting for 10 thousandths once it's readjusted, but we got to get it out of whack first so you can do the adjustment. And I'll get you the wrenches here. It was a couple of put the camera up there and kind of walk over. You loosen all the outside ones up first, and we're going to get it out of whack on purpose so you can practice actually setting that gap there. This is used in the turkey plant where they have a processed butterball turkeys. It's used for raising and lowering a plate that's involved in vacuum packaging some of their processed turkey meat. So it does a really fast action stop. Just a nice indexing motor that lets you get a controlled stop there. So if you bring these out, you bring them out, get them out of the way there. Yeah. Exactly. So we know that we're way off base now as far as that gap in there. And now, so let's get our feeder gauge. Let's see. Yeah. Go with the manufacturer's information. I just showed you quickly here where do we get information from on this gap that we're talking about. And seriously, this motor come over here from Butterball, and they didn't send this information with it. So I went online, good old Google, and I Googled that information. Flip it around, flip the motor in. Let's look at the data plate on there. So if you don't have data on setting up a motor, and it requires some type of adjustments, here's what I would recommend. You go to the data plate there, Coel, and it says Italy. So it's an Italian brake motor right there. Y'all see that? All right, that's fine. Yeah, that little, yeah, good. Get the glare. And you see that good? Perfect. So there you go. It's made in Italy. And I went online and I found that company. And then using the data on there, you got your type, you got your number and all that. You got all this data on here. And I was able to find a data sheet for it and download it. And so here we go. As you read through this, it tells you over on the third page. It goes to your main information right there if you look. It says that the magnetic gap, the distance between the electromagnet and the mobile anchor, must be adjusted to approximately in millimeters 0.3. Now 0.3, if you convert that, you can take your phone and go to Google and say convert 0.3 millimeters to inches, it'll be about 10 thousandths of an inch. So we're using a 10 thousandths feeder gauge to do this. And so we go over here. There's a different feeder gauge leads in there. We're going to pull out 10. So that's what Coel recommends, 10 thousandths of an inch. If you notice here, that 10 thousandths is converted to 0.25 millimeters. If you round to 0.25, if you round it to that position, it's actually 0.3 in their specs there. If you round it, I mean they obviously did round that, so it's about 10 thousandths. And so I'm going to give them guys the feeder gauge, and they're going to set the gap in there. You're looking for a gap in here. Right over here. The friction pad, if you see the friction pad, like right now, when it look, you got to have this here engaged right here. Just have to be, yeah. I forgot to tell you that. That has to be engaged, and that actually releases it. Then you set your gap like that. So, important detail is that calibration bolt there. It has to be fully engaged, real tight. So when it's in there like that, what that does is it simulates put power on that coil, and it will pull against the springs there. And now, yeah, they're lock. Yeah, they're lock nuts. They're lock nuts. Yeah, the lock nuts. Whenever you get the set right, then this nut has to lock against that one so it can move. To keep it from moving, exactly. They have to. Right, you have to move. Yeah, you have to move. It didn't move. But your gap, you can get, you're going to check the gap in there between that friction pad and that metal plate. You get a gap in there. So if you put the feeler gauge in there now, did you have any gap at all? You don't have any? You got me all three of them. Yeah. It's when you only have three like that, one of them really affects the other. You know, when you do one, it throws the bounce off. You know. There's a gap in it now, ain't it? Yeah. Yeah. So you're shooting for 10 thousandths near each one of those studs, the three, and you want to have it so it's got a little bit of drag to it. You want a little bit of drag, a little bit. Y'all see what he's doing there? So he's shooting for a little bit of a drag with 10 thousandths. He's going to continue to do that at the location of each one of the studs until you get a little bit of drag there. And that'll allow it to the rotor to turn without dragging, but yet not have too much of a gap to close in whenever it's engaged. rotate the whole thing around. These guys are for hire. They're about $33 an hour is they're starting off. Ain't that starting off for guys about 33? That might get it. He said might get it, might maybe. Mm-hmm. If you look at where he's checking it at, you've got a friction pad in there that has that sparkly color to it, it's like a semi-metallic. That's your friction pad, the black, and then you got metal plates that it's going to come against when it engages. And the coil, that electric coil on the back is what's going to pull to close that gap in. So he's continuing to check for some a little bit of drag there with that 10 thousandths feeler gauge. As Darren brings that in. And then you want to go back and check. You know, when you can get that drag on all three of them, then you're set. Then you rotate all around. It's a big old teeter-totter deal there. You have to keep going. You be careful with your wires there. You can't close still. Now, so you want to lock those nuts in. Your jam nuts. You want to lock them in. You can put one wrench against the other one so your adjuster doesn't move. You got the jam nuts there to keep you from losing that adjustment that they just did there. So do you feel drag on all three of them? You actually feel a little bit of drag on them. Okay? Okay. So now you spin the motor shaft. See, does it spin free? Nice and free. Do you hear any dragging? See it spinning nice and free. There's a little bit of warpage in there, and that may be why it got donated. It's got, because it's not, it does have a little bit of warp to it, a little bit of wobble. But I don't hear any dragging in there whatsoever, no scraping at all. I don't hear any of that. Okay? Now, so we are, and all your jam nuts tight. So we're going to wire the thing up. We're actually going to wait till, because it's actually 10:20. The next step is to wire that up, the three-phase motor part, to the bottom of that motor starter. So we'll hook 3 wires up to the bottom of that starter in there and hook the ground wire to the outside screw. Yes, you're going to take off You're going to take out that bolt, that adjustment bolt, that calibration bolt that comes out. And then the cover goes back on. Make sure that it's actually all the way on, so this is flush on the end. Right, nice and flush. And if that doesn't go back in, if you do that, it's always going to freewheel. You can't have it in there when you run.
Oh, this?
Not when it runs, because like if you put it in, it's always going to spin the brake whenever it engages. So this is a special. Actually, it's a hollow bolt there that you do this adjustment. So this is a very critical player here. Right now, without the bolt in there, if you look up front, see if you can turn that brake there. Turn the shaft. It's actually locked up. You won't move it all with it. So that brake is really engaged very well right now. And so we're going to shift over. Okay. Going to shift over and connect the motor to the starter. It's actually going to go up in there to the bottom of the motor starter. Right. That's the terminal strip there. Get that. Let me point. I'll show you.
It's got on the bottom of this here with the three terminals.
You got to go down in there. Right there. Got those three right in there. Mm-hmm. We'll slide the motor out this way some. I'll get the camera in there a little bit closer. So he's going to the bottom of the motor starter there. Once he gets him tied in, I'll zoom the camera in that you can see a little better where he's at. Hard to get that angle right there with his hands in there. Right. But this is a motor control bucket, they call it a bucket. It slides into a motor control center structure. And it's a modular type of motor control. And this motor is a three-phase motor. It's got 3 hot wires. It goes to a motor starter, and it applies 480 volts to it, 3-phase. And then there's a ground wire that grounds the frame of the motor. Yeah, you want to go. If you look up under there, there's it has to get inside the clamp. The clamp. You can actually, if you want to tilt the whole unit, we can, so you can see it better. Right. That's a good idea right there. You can sort of see up under there. I'm going to wait with the camera until he gets it done, and then I'll put the camera inside there.
This is
right. Hopefully, you might. Darren's in there. He might want to. How about if I get the motor out of your way here, son? Let him step in. Once they get it connected, we'll put the camera inside and let y'all see where the connections were done inside of the the starter. That's a tight spot. You got big hands, ain't it? Yeah. But that's pretty real stuff that, you know, that's stuff that you'll run into depending on where you're working at. I mean, you can run into some tight spots like that even working on hog farm. You know. So you working with hogs or turkeys or what?
Both.
With both? Okay. So do you have any tight spots there you work in?
Not really.
Oh, really? Okay. That's actually a good shot right there. That's just what he's up against there. He's trying to make the connections there at the bottom of that starter. And if you'll pull on each one of them, make sure they won't come out. So y'all can see there. This I got the camera's kind of turned sideways, but turn if I go this way. That's the actual, that red bar there when you push it, that's a reset bar for the overload. Press that, you press that one time. Press it again. That's what you press if you have an overload. The motor trips out there, that's that. But down in there, that's your three connections for your three-phase power going to your motor. And over there, there's a dial. There's a dial in there behind that. That's where you adjust your motor, your trip point. So if you open that window up and you adjust that dial, you can actually set your trip point. And your grain you can get to from the outside. Flip around, there's a screw you can get to. Actually, the top you go on. Right there where the screwdriver is, and right there, right in there. You can just go behind that washer. That's just an easy way to get to it without having to disrupt anything else. And here, we got three-phase power coming in to the top of the motor control bucket. Goes to a circuit breaker. It leaves a circuit breaker and comes over to the top of the starter here. And that's the top end of the starter with the 480 volt going in three-phase. And then you just saw the bottom end of it where he tied to. He's got the ground wire hooked up over there. Okay, so it's ready to energize, and I'm gonna ask you guys. It's 10:20. Do you want to fire it up now, or you want to wait to Thursday?
Wait Thursday.
That's exactly what I would do because it's 10:20 right now. So we're going to wait till then. We're going to save that so that you guys can get on to what you got to do. And in the same here, I got some get ready for another class for ELC 111. And
If you give me one of those the on-call pie chart sheets
the whole sheet.
and bring to the bus, please.
Yeah, I'll have them with me.
All right.
I'll have them with me. Yeah, yes, sir. Yeah.
Have a good one.
You too. I've actually got one. I got one in my bag right here. If you want it now, I've got one right here.
I'll get it.
Okay, all right. Sounds good. Appreciate you guys. You guys did an awesome job there. So if we back up the camera here, we have the brake motor has been wired. They got the ground wire up here. That's not where you would normally hook it up, but that's just a quick way to do it here in the shop, just for just a very temporary thing. And the 3 phases are going down to the bottom of the motor starter. If I open up the control here, then you can see the entire starter. If I back out, that's the big starter right there. It comes in, the 3-phase comes into the top of it, goes in, and it bleeds out the overload at the bottom, and there goes the 3 yellow wires right there that goes to the motor. There you go, and that's it. So we're going to save this to energize it Thursday in class. You'll be able to see it watch it run, and it'll start very quickly, and it'll stop on a dime with no coasting at all. It's just a very fast indexing type motor. And what they're doing at Motorball is they have a sensor. This thing here is running some type of a plate up and down. It goes up to position and stops, and then it goes up again and stops, and then comes all the way down. So it has a mid position in a center travel position where it stops. So when that plate gets up to a proximity sensor, the proximity sensor will cause the starter to disengage and cut the power to the coil for this. So when it shuts the coil off, it de-energizes these wires here, and it de-energizes the windings on the motor, and it also releases the brake engages, and it grabs and it shuts that shaft, stops it very quickly. So that when it hits that center position in the process for vacuum packaging, their processed turkey meat is for vacuum packaging. It positions some type of a vacuum process. When it gets up there, it stops and it does, and then it moves up and then it goes down. I don't have a picture or a video of the process, but just in a nutshell, this is a good for precise positioning of machinery. The next thing up from that would be something like a servo. It would be a lot more expensive than that in that size range, horsepower range. Servos are very, very expensive, and the controls are very expensive. And I've requested some to have here at the college, and I'm hoping that it'll get approved for XY positioning on our automation system there in the back. So I'm hoping we can get that maybe early in 2021. So we're going to stop this session here. And if y'all have any questions, you can contact me. Email is dking@samsoncc.net. Glad to help you with anything you've seen or help you get enrolled in some classes. Answer any questions you have. We do have, I teach electrical classes, some mechanical, hydraulic, pneumatic, and a variety of things, but mostly electrical is what I teach. We have motor controls, PLCs, and various things. Automation class with advanced PLCs, and I'll be glad to get you enrolled and get you learning some things that's going to help you step it up in your career. Hopefully make more money. Thank you. Have a blessed weekend. Thank y'all for watching, and we'll see you Thursday. And Patrick and Brandon, y'all have a good one. Thank you for watching, and have a blessed week between now and Thursday. It's not the weekend yet, but it's but I'll see you Thursday. And thanks for joining.